Hello guys and welcome back to the channel. In this video, as usual, we'll be taking a difficult concept from junior cycle science. We'll be breaking it down into a small, simple pieces and giving you guys some practice to do so you master the content. A quick reminder that you should turn your phone on to silent and you should close any open tabs, especially social media, as that's just going to distract you. And we're going to begin today's video by just a quick recap of something really important from the last video. So I'm going to start with a couple of questions. And as I always say, it's really important you're actually going to do the questions and not just wait for the answers. Otherwise, you're just not going to get as much from the videos. So what I want you to do is pause the video and answer these two questions in your copy now, please. All right, so you should only be watching if you've answered the questions. Very quickly, what makes atoms stable? So you will recall from the last video, I told you that atoms are stable if they have a full outer shell of electrons. Now, I'm not writing a full sentence here. I'm just writing what the key part is. You should have a full sentence, and it should definitely include that they have to have a full outer shell of electrons. That's what makes atoms stable. Which group of elements are highly stable? These would be the elements of group 8, sometimes called group 0. Okay, now I got into the reasons for that the last day. Group 8 or group 0, and they also have the nickname of the noble gases. Okay, so either of those things is correct. Okay, so let's quickly reestablish that atoms are stable if they have a full outer shell of electrons. That leads nicely into today's video. We're going to be talking about something called ionic bonding, but I don't want you to worry about that title until the end. Okay, just stick with me because we're going to build the ideas up one by one. So we just said atoms are stable if they've got a full outer shell of electrons. Well, if we look at metals, let's start with metals. We can quickly clarify something. We know that metals are on the left-hand side of the periodic table, and they're in groups 1, 2, and 3 usually. So metals are generally in groups 1, 2, and 3 on the periodic table. So metals are, and that means that they always have, if they're in group 1, they have 1 electron in their outer shell. If they're in group 2, they have 2 in their outer shell. If they're in group 3, they have 3 in their outer shell. So this isn't a new idea. We've already seen that. So metals always have either 1, 2, or 3 electrons in the outer shell. So metals always have either 1, 2, or 3 electrons in their outer shell. And we know that this is not full. They are not full then if they've only got 1, 2, or 3, because 8 is full. Or if it's helium, 2 is full. Again, we'll take a little look at that little thing in more detail, but usually 8. Group 8 means 8 electrons in the outer shell. That means the shells are full. So metals have either 1, 2, or 3 electrons in their outer shell. This means that metals are not stable, because we know that they would like to have 8 electrons in their outer shell. So metals are not stable. So they would like to be stable. So how does this happen? Well, let's just take an example of a metal. Lithium is an example of a metal. If we take lithium on the periodic table, lithium has the number 7. So it's got an atomic mass of 7 and an atomic number of 3. What do we know about this number 3? This tells us 3 protons. Lithium's got 3 protons and it's got 3 electrons. Because I told you that atoms have the same number of electrons as protons. Why is that? Well, each proton has a plus charge. So here are the 3 pluses from the 3 protons of lithium. And to balance that out, they also have to have 3 electrons, because electrons have a -1 charge. So if they've got 3 pluses and 3 minuses, overall, they don't have a charge. And that's the way atoms are. So if I was to draw this atom, we would have lithium like this, Li. And if we were to then try and draw the electrons, I'm just going to turn that off. Draw the electrons. We've got 2 electrons in the first shell, and we've got 1 electron in the third shell. Like that. Okay, we've got, sorry about that. We've got 1 electron in the third shell, like that. And if we were to write the electronic configuration, we would say it's got 2, 1 electrons, like that. Now that obviously is not stable. This is an atom of lithium. It does not have a full outer shell, so it is not stable. How could it get a full outer shell? Well, it could, as you can see, if it wants the second shell, This here is the second shell. If it wants this to be full, then it would have to gain 7 electrons. It would have to get 7 more. Now, this is something that would not be easy to do. There's not like 7 electrons floating around that this lithium atom could just like suck up and fill up its shell. That does not really happen. The other way that this could happen is actually if it lost this electron that's in the second shell. If it was to lose this electron, then that second shell would be empty. And we would say then the outer shell is the next one inside. This one in here then would be the outer shell. So the one in the middle. And that has two electrons in it. And we know that that first shell, if it's got 2 in it, then it's full. Okay, so hopefully you get that idea. So we're going to say that the lithium atom loses 1 electron. It loses 1 electron. Now, I'm going to talk about atoms losing electrons. I just want to point out a really important idea. It's not like these electrons just disappear and vanish into thin air. It loses it. Oh, well, where does it go? There is a bigger picture here that I'm not going into because I'm just trying to keep the idea simple for now. But very basically, where is it going? Well, there's another atom that wants to take it. So there's another atom that's going to take the electron from lithium. We're just looking at lithium, so we're going to say lithium loses 1 electron. Where does it go? Sorry, excuse me. Where does it go? It doesn't disappear. It goes to another atom. But we're not drawing that right now. But when we look at it, again, we're going to build up to it, and you will see that there actually is another atom taking this electron. So what does lithium look like after it loses 1 electron? Well, now it's still got lithium in the nucleus. It's still got Li, its symbol in the nucleus. And it's now got 2 electrons in the first shell, and that's it. That's actually all it's got now. So then there is a full first shell of electrons. 2 in the first shell is full. Okay. But note what's happened now. We still have 1, 2, 3 protons. We still have 3 plus charges because they haven't gone anywhere. The 3 protons are still there. But now we've only got 2 of the minus charges left because we've only got 2 electrons. So overall, if we were to just say they cancel out, overall this atom has a positive charge or a +1 charge. It's got 1 extra plus. It's got a +1 charge. And we show that like this. We use a square bracket. We put square brackets around this thing and we show that there's a +1 charge on it. Now, we could write it as +1, but generally when there's ones on maths or science, we don't go around writing the 1. So we just call it plus. The configuration now, actually, instead of being 2, 1, is now just 2. And again, we use a bracket to show, well, this actually there's something else going on here. It's actually 2 with a plus. This thing here is what we call a charged atom. It's an Li with a plus charge. This is what we call an ion. It's not an atom anymore. It's a charged atom. And charged atoms we call ions. So this here is what we call a positive ion or a positively charged ion. This is a positive ion, but the word ion just means charged atom. So we've seen a rule here. Lithium is in group 1 on the periodic table. And a rule here is that group 1 elements, group 1 metals, always form +1 ions. Okay, so this is the group 1 metals, always form +1 ions. Let's take a look at a different atom. Let's take a look at, instead of lithium, let's take a look at this guy, beryllium, Be. So Be, we'll take a look at this one on the periodic table. Be has the numbers 4 and 9. Okay, so the 4 here means 4 protons and 4 electrons. So if we were to draw this out, we would have Be. Beryllium has 2 electrons in the first shell, and 2 electrons in the second shell, like that. Electronic configuration is 2, 2, just like that. Now, again, there are 2 options here. Either beryllium could gain 6 electrons to fill up the second shell to make it 8. Again, this is very hard to take 6 electrons from another atom. The other option is that it could lose 2, or atoms could take these 2 on the outside. And that is what's going to happen. So beryllium loses 2 electrons, like this. Loses 2 electrons. So if we were to draw beryllium now, we would have Be. We would have 2 in the first shell, and that would be it. That's all it's got. Now we have to show that this is now a charged atom. So we use the square brackets again, like this, square brackets, and it's now Be2+, like that. Okay, so notice that this time there is a number because it's not 1, so we are putting in, there's 2 pluses. There's 2 extra protons because there are 1, 2, 3, 4 protons that we know from over here with the atomic number of 4. And now there are only 1, 2 electrons left. So overall, there are 2 extra pluses. So we say it's got a +2 charge. So this now has the configuration of 2, but it's 2 with a 2+. This gives us another rule. Beryllium is in group 2. So all the other elements in group 2 will do the same. Group 2 metals always form +2 ions. Okay, +2 ions. Or actually, I'm writing that in the wrong order. It's actually what we would call 2+ ions. Okay. I'm just going to pause the video for a second. Okay, so hopefully you've seen the pattern what's going on here. We've looked at group 1 metals, we've looked at group 2 metals. We're now going to look at group 3 metals, and you're going to finish this off for me. Okay, so a group 3 metal is the metal aluminium, the element aluminium. Aluminium, okay, aluminium has the numbers 3 and, sorry, not 3, 5. 5. Scratch that, apologies. I've changed my mind. I've decided we're going to do it like this. We're going to fill out this table, guys. Okay, so we're going to look at this table. I'm going to show you how to fill out the first one. Okay, so we're going to look first of all at group 1. Okay, so what I want you to do is I want you to pause the video and I want you to actually take down this table, just the outline of it. Okay, so you should only be watching if you've got the outline of the table taken down. I'm going to show you how to do the first one. Okay, so we're looking at group 1 here. So group 1, the first thing we have to do is write down the number of outer electrons. So if it's in group 1, that means it's got 1 outer electron, 1 electron in its outer shell. So how many electrons are going to be lost or gained? So if it's in group 1, it's got 1 electron in the outer shell, it's going to lose 1. So we're going to say 1 lost. So 1 electron gets lost if it's in group 1. Charge on the ion that it forms, well, if it loses 1 negative charge, it's now got more protons than electrons, which means it's going to have a +1 charge. +1 charge. And the example of that is going to be lithium plus, Li plus, like that. Okay, so what I want you to do now is I want you to pause the video and do it the same thing for groups 2 and groups 3. Okay, so you should only be watching the video now if you've done this for groups 2 and groups 3. All right, let's have a look at what you've got. Okay, so we've got here group 2. So outer electrons, it's got 2 outer electrons, 2 electrons in the outer shell. Electrons lost or gained, it's going to lose 2, so 2 lost. Charge on the ion, it's going to be a +2 charge. Well done, if you got that right. And an example is Be, beryllium plus. 2+, sorry, beryllium 2+. You can also take a look at group 2 and find another one. It could also be magnesium, Mg2+. And likewise for group 1, you could have also had Na+, sodium+. You could also had K+. So any of the ones in group 1 will all be the same. All right, so group 3 was where you had to do a little bit by yourselves. Okay, so outer electrons, if it's in group 3, It's got the same number of electrons as its group, so it's got 3 electrons in the outer shell. Well done if you got that right. If you didn't get that right, pause it and fix it and do the rest of these now. Okay, so electrons lost or gained, it's gonna, if it's in group 3, it's gonna lose 3, so 3 lost. As you can see the pattern, metals always lose electrons. Charge on the ion, it's gonna have a +3 charge because it's got 3 extra protons than it does electrons now because it's lost 3 of its electrons. Examples, well, if you go to group 3, you'll see you could have boron, B3+. You could have aluminium, Al3+. Those are probably the 2 good ones. Just a quick recap, actually, maybe I didn't explain this well enough. When we're writing the charge, Li, we should write it like we would if we were writing something square. This is what we call a superscript. Superscript. If we're writing like, 3 to the power of 2 or 3 squared. It's the same kind of way we write the charge on an ion, okay? All right, let's go on now and look at some non-metals and what they will behave like. So we know that the metals lose electrons and become positively charged ions. Let's look at some non-metals. Well, we know what the non-metals are on the table. They're on the right-hand side of the stairs. And there are a few different groups that are non-metals. Okay, so let's have a look. We have non-metals in groups 5, 6, and 7 do not have full outer shells. It's the same idea. They do not have full outer shells. They want to be stable. They want to be like group 8. So they will try and do something to get a full outer shells. So do not have full outer shells of electrons. That is non-metals in groups 5, 6, and 7. They do not have full outer shells of electrons, and therefore we say that they are not stable. They are not stable like the noble gases are, and they would like to be. Let's have a look at an example. This here is the element nitrogen. Nitrogen is in group 5 of the periodic table. Its numbers are 7 and 14. So it's got an atomic number of 7 and it's got an atomic mass of 14. This is how we draw it. So nitrogen is N in the middle. It's got 7 electrons because its atomic number is 7. It's got 2 electrons in the first shell. And in the second shell, we've got to put 5 more. So we have a total of 7. 1, 2, 3, 4, 5. Now, the way that this could get a full outer shell is either it could lose these 5, or to get to 8 in the outer shell, it could gain 3. And that's what it's going to do. It's going to gain 3 electrons. Now, remember when I told you earlier that the metals could not just lose, they don't just disappear them electrons. Well, nitrogen can't also just magically make 3 extra electrons. So it's going to be taking electrons from some metal atoms, okay? So it gains 3 electrons. If we were to have a look at the nitrogen in the beginning, it's got electronic configuration 2, 5, like this. Well, what will it look like after it gains 3 electrons? Well, it now has nitrogen in the middle, like that. It's got a full first shell, 2 electrons. And it's also got its 5 electrons that it had before, that I'm drawing with X's here. But it's now also got 3 extra electrons that I'm drawing here with dots. These are showing the extra electrons that has taken from another atom. Again, what's happened here? Let's take a look at the charges. Well, we know that nitrogen has 7 protons. That's 1, 2, 3, 4, 5, 6, 7, like that. And it used to have 1, 2, 3, 4, 5, 6, 7. It used to have 7 electrons. But now it has gained 1, 2, 3 more. it now has more electrons than it does protons. So this is now a charged atom. Charges are not balanced anymore. And it's got 3 extra minuses. So it's a 3 minus ion. So this is an ion again, because it's a charged atom. And it's what we call a negative ion. It's negative because it's got a negative charge. Its electronic configuration is now 2, 8. And we show that it's got a 3 minus charge. So we have a rule here. This is an element from group 5. So the rule for elements in group 5 elements always form 3 minus ions. When they form ions, they form 3 minus ions. Okay, that is their charge, 3 minus. That is nitrogen is an example of an element from group 5. Let's take a look at an element that's in group 6. This is oxygen. O. Oxygen, sorry, over here. Oxygen has the numbers 8 and 14 and 6. Yeah, 8 and 16. Sorry, it's got the numbers 8 and 16. I'm now drawing oxygen. Oxygen has 2 electrons in the first shell. And it's got 1, 2, 3, 4, 5, 6 electrons in the second shell. The fastest way for it to gain a full outer shell, or the easiest way, is for it to gain 2 electrons. So this non-metal oxygen gains 2 electrons, and it goes from 2, 6. If it gains 2 more, it goes to 2, 8. But the charge on that is got 2 additional electrons now. The charge is going to be 2 minus. We would draw that like this. O, with 2 electrons in the first shell. 6 electrons of its own with X's that it originally had. 1, 2, 3, 4, 5, 6. But it has now gained 2 extra electrons from some other atom that it took them from. And the charge we show as a 2 minus charge. So this is an element from group 6 on the periodic table. Group 6 non-metals always form 2 minus ions. They're in group 6, they form ions with a 2 minus charge like that. Let's take a look at an element in group 7. Okay, here is an element from group 7. The element is fluorine. Fluorine has 10 and 19 as its numbers. If we draw fluorine, it's got 2 electrons in the first shell, and it's got 7 electrons in the second shell. So it's almost stable. It just needs 1 more. So fluorine is going to gain 1 electron. Gains 1 electron. If it gains 1 more, it can have 8 electrons in the outer shell. So how do we draw that? Well, fluorine, which still has 2 electrons in the first shell, and 1, 2, 3, 4, 5, 6, 7 of its own with the X's, and here's the new one that it's just gained, the extra one that it took from another atom. We show that it is a charged atom, what we call an ion, using a minus. Now this is really -1, but because it's a 1, we can just write minus. Okay, and the configuration goes from being 2, 7 to 2, 8, but it does have a charge. 2, 8, it's a minus charge. So the rule here is that group 7. Apologies, I think my screen is going to crash. Yeah, I'm just going to pause the video for a second. Sorry about this. We're back. Okay, so we have group 7, and these are non-metals. Group 7, non-metals. Always form, geez, sorry about that spelling, that's terrible. Always form -1 ions. Okay, so we've got fluorine, F-, chlorine, Cl-, bromine, Br-. So any of the elements in group 7 will always form -1 ions. Okay, so there we have a variety of rules. Okay, so hopefully those are something you're going to remember, but let's practice now filling out this table similar to the one that we did before. So I want you to pause the video, draw the outline of the table and fill it in for me. Do that now, please. Okay, so you should only be watching if you have done this table and you have filled it out. This is what it should look like. The outer electrons, if it's in group 5, that means it's got 5 outer electrons, 5 electrons in the outer shell. Electrons lost or gained, well, it's going to gain electrons. Think about it, it's closer to 8 in the outer shell. It's closer to 8, so it's going to gain. If it's closer to 1 or 0, it's going to lose. Okay, so electrons lost or gained, it's going to gain 3. Gains 3 electrons. What charge will it have then? Well, it's got 3 extra electrons now. It's 3 more electrons than it does protons. So that's going to have a 3- charge or a -3 charge. And an example would be N-3 or N3- actually. N3- like that. Okay. What about group 6? Group 6 have 6 outer electrons. What are they going to do? They're going to gain 2 electrons. What charge do they have? Well, they now have 2 extra electrons than they do protons, so they're going to have a 2- charge. And an example would be oxygen, O2-. If you check under oxygen, you also have sulfur there, S2-, and so on. Any of the elements in group 6 are going to be the same. What about group 7? Group 7 have 7 electrons in their outer shell. Electrons lost or gained, well, they're going to gain 1. They nearly have a full outer shell. They just need to gain 1 more, gain 1 electron. What charge do they have then? Well, if they get that extra electron, they've now got 1 extra minus than they do, 1 extra minus charge than they do plus charges. So it's going to be just -1. And an example would be either F-, Cl-, or Br-. Those are the main ones that we look at. All right, so that there is how we've looked at putting together or summarizing what each group's elements will do to get to in order to be stable. So let's just summarize now. Okay. What is an ion? Well, we know that an atoms can gain or lose electrons. So atoms that have lost or gained electrons to become positively charged or negatively charged. Okay, so we know that atoms can lose or gain electrons. When they lose electrons, they become positively charged. When they gain electrons, they become negatively charged. We call these things ions. So ions are atoms that have lost or gained electrons to become positive or negatively charged. Sorry. All right, so what I want you to do is pause the video, take down that definition of an ion now, please. Ions, atoms that have lost or gained electrons to become positively or negatively charged. Take that down for me. And let's summarize the process. If an atom loses electrons, like the metals, loses electrons, what happens? The atom becomes positively charged. because it's got more protons than it does electrons. It becomes positively charged. Okay, and we show that using a plus, positively charged, and that's because it's got more protons than electrons. That's why it's positively charged. What happens if it gains electrons? And these are like the non-metals, group 6, group 7, group 5, group 6, group 7. If it gains electrons, then it's going to become negatively charged, which we show using this sign, negative. And why does that happen? Well, it happens because it's now got more electrons than protons. So an atom now has more electrons than it does protons. Okay, I would advise you to pause the video and take down that summary. All right, you ready to do some practice questions? All right, let's have a look at some practice questions for you guys now. All right, so what I want you to do is I want you to get out your copy and I want you to pause the video and do these questions for me now. So a reminder that if you're not going to do the questions, then you're not going to actually learn as much from watching these videos. So I want you to pause the video and do these questions now, please. Okay, so you should only be watching the video if you have tried the questions. Let's have a look at these and go through the answers. So it shows a particle. It's a sodium particle. Okay, and it says examine it carefully. True or false? The diagram shows an ion. Now, it does show an ion. Okay, so it's true. So if you said true, well done. Now, it might have been hard to recognize that it's an ion because I actually did not draw the brackets and put the charge on it. But what I wanted to see is whether you guys could count the protons and the electrons and figure it out. So if you said that it was false, that it doesn't show an ion, I want you to take another look and then tell me the answer to number 2. Okay, so pause the video and have another look if you haven't already said that you did think it was an ion. Okay, how do you know? How do we know that it does show an ion? Well, if you look carefully, you will see that this here, sodium, has 11 P's or 11 protons, like this. But if we look carefully and count the electrons, we've got 1, 2, here's 2 more, 4, 6, 8, 10. Okay, so we've only got 10 electrons. So if you work out the charge on that, 11 protons, 10 electrons, there's 1 extra proton. So this would be a +1 charge. And that's an atom with a charge is an ion. So how do you know that it's true? It's got more protons than electrons. That means it's going to be an ion. That's how we know. Now, of course, if I was really going to draw this for it to be fully correct, I should draw it like this to show that it's positively charged. But I wanted to see if you were able to recognize it without that bit, just by counting. So well done if you got that right. Let's have a look at number 3. An ion is an atom that has lost or gained something to become charged. This should be electrons. Well done if you got that right. Electrons. Let's have a look at number 4. A positively charged ion has more protons than electrons. It has to be in that order. If you wrote them the other order, then it's wrong. So it has to have more protons than electrons if it's going to be positively charged. If it's negatively charged, then it has to have more electrons than protons. So again, if you got that right, well done. If you didn't, fix them. Okay. All right. Last little bit. So what does it matter? All these things, these atoms that are charged, why does that matter? What does that cause? Well, note that sometimes, not sometimes, like I explained to you at the beginning, if an atom is losing electrons, another atom is always taking them. So we usually have like a metal and a non-metal together, And when we put them together, the non-metals are going to take electrons from the metal atoms. Okay, so we've already seen that metals, if we have a metal, metals will become positively charged ions. Positive ions. They will have a plus sign, okay, because they will lose electrons. So metals become positively charged ions. And we're just going to draw that. We're going to symbolize that by just drawing a circle with like a big P in the middle to show that this thing is positively charged. Now, we never just have a positive charge thing on its own because we've always got something around it that has taken the electrons from it. So we usually have a non-metal in close proximity, in other words, in the same location. We have non-metals, and non-metals, they make negative ions. They take electrons from metals, negative ions. So these are negatively charged. So I'm going to draw that using a big blue circle and a negative charge. Now, we've already seen what happens to things which, when we study charge, what happens to things which are oppositely charged. What we have here is two things that we call oppositely charged ions. Now, what I'm drawing here in orange are some lines. These lines aren't a real thing. They don't really exist. They're not like lines stuck between two atoms. But the lines here represent something. They represent a strong attractive force. A strong attractive force. So like we said, opposite charges attract. That's what we said in the beginning when we looked at charge as a property. Things which are oppositely charged attract to each other. So when we get this creation of oppositely charged ions, then we end up having a positive and negative charged atom, and those two things, or these two ions, are going to essentially stick together. And we get this happening loads and loads of times in a mixture, because we know a mixture contains loads and loads and loads of atoms. So they're all doing this, making positive and negative atoms. When they do that, when we've got these ions, they stick together in big groups, positives and negatives, attracting each other into a big group. Okay, so we say that we get these attractive forces, attractive force between oppositely charged ions. And we call these attractive forces between oppositely charged ions, we call these an ionic bond. So the ionic bond is shown by the orange lines here, the force of attraction between oppositely charged ions. Now note, ionic bonds are not these things where electrons are being lost or gained. This is the process that happens before a bond is made. Ions have to be formed. So up here, atoms losing and gaining electrons. This is forming ions, okay? But then when ions are formed, when you've got positive and negative ions, they stick together. That's the bond, okay? So it's shown by these orange lines. So that is what an ionic bond is. So this is how atoms end up sticking together sometimes. You get atoms want to be stable. They will either gain electrons or lose electrons. And when they do this, they create positive or negative ions, which then stick together in groups. And that's how we can get a compound, because we've got these different charged ions really strongly held together by a bond. So I know that's a difficult idea. What I want you to do is pause the video and take down what you can see in the screen. So take down the definition in the box, and a little diagram here is a good thing to have as well. All right, time to do some more practice questions now. All right, let's take a look at these guys. All right, so I want you to pause the video and answer questions 1 to 6 here. All right, so a reminder, you should only be watching if you've tried your best to answer these questions. So first of all, what is an ion? So again, hopefully you've mentioned something to do with charge. So an ion is just a charged atom. Now they can be positive or negative, but they're just atoms that have a charge. Atoms that have lost or gained electrons and have a charge. So they're just a charged atom. That's what an ion is. So atoms which have lost or gained electrons and become positively or negatively charged. These are ions. You took that down as a definition. So you need to make sure that you learn it. Below are 3 ions. So you see a diagram with these 3 ions. What do the orange lines show? Okay, so the orange lines show what we call ionic bonds. Well done if you got that right. If you explain what they were, even better. So ionic bonds, what are they? If you didn't explain already, I want you to pause the video and explain. Okay, so what are they? These are forces of attraction. And why do they exist? Because you've got oppositely charged ions. So forces of attraction between oppositely charged ions. That is an ionic bond. Which ion, black or red, would be a metal? Well, the black one is the positively charged thing. And I know that metals always become positively charged ions. So the black would be the metal. Well done. If you got that right, good job. If not, then you need to have a think about it again and do understand why. Don't just mark it an X and go on. Do have a think about it. How do you know? Well, how do I know? Because it's a positively charged, which means it's lost electrons. So it has lost 2 electrons. Metals lose electrons. It has lost 2 electrons. So that means it was in, if it lost 2, it was in group 2. And group 2 are metals. What is an ionic bond? So I've already explained that in orange above. It's a force of attraction between oppositely charged ions. So again, hopefully you have that force of attraction between oppositely charged ions. So I've covered that already, so I'm not going to write it down again. Why do the red and black ions form ionic bonds? Why do these red and black ones form ionic bonds? Well, we obviously have positive and negatively charged things. So they are oppositely charged. And oppositely charged things attract. Oppositely charged, which means they attract. That's why they form ionic bonds, because they are attracted to each other because they're oppositely charged. Why are there no ionic bonds between the 2 red ions? So here, in other words, why is there no ionic bond here between these 2? Well, think about their charges. Okay, these are both negatively charged. So these have similar charges or the same charge, which means they are not going to attract. They are actually not going to want to be anywhere near each other if possible. They want to push each other away. They repel. So why are there no ionic bonds between the 2 red ions? Well, the key thing you have to have in here is that they have the same charge. So they have the same charge. And things with the same charge, they don't attract. They repel. They push each other away. All right, so I appreciate that some of the ideas in this video are a little bit of a step up, a little bit hard. So I hope I've explained them pretty well. I hope you've been able to follow and you've got the answers right. If you need to, again, parts of this video, it's a good idea maybe to go back and have a listen again and make sure you're getting the key ideas before we move on. All right, that's it, guys. Thanks, and I'll see you in the next video.